G'day everybody, where's Wally here. Nathan, I see you're struggling with this a little bit, mate, but it's okay to measure from a local flat plane. Now there's your sound grab for you, mate, and I even left a little bit of gaps on both sides just so you can clip it out really easy like. Now you do realise, Nathan, old boy, I always do things for a reason. I tossed this line out and you took the bait, hook, line, sinker, rod and boat. Do you see what demonstrable reality this is? Now Nathan is coping with the final experiment's imminent wrecking of the flat Earth model. He's claiming that Earth is measured flat every time you mention degrees or angles or, lol, even azimuth angles. The Nathan parrots all chant flat Earth angles. They think that they're all derived from angles to Polaris. Trouble is, Nathan, that every time a Flerf tries to validate that claim, they soon get slapped down by demonstrable reality. Now, Flatsoid tried this a while back. Nathan, you should go and ask him how it went. Oh yeah, sorry, that's right, you can't, can you? Flatsoid shut you down for being a demanding princess and told you to go grow a pair.
I'm sorry, Nathan is a prick, and I'm going to keep on saying that. Nathan is a prick, okay?
I agree, 100%.
His vulgar attitude is what got him in the first place where he's sitting. Him playing victim that people don't like him is his own doing. Okay, I always supported the guy. I had nothing against. I still have nothing against him. But he mustn't play baby and everyone feels sorry for me because of his own vulgarity. Okay, I don't give a shit if he thinks, everybody must just say Earth's measured flat. If he wants to do that, his thing. We all have our own channels. We all have our own arguments. Okay.
Oh darn, that's the wrong clip. But I guess you get the point, don't you, Nathan? So you can see here on a flat plane, you can't have the distances remaining constant along the horizontal axis and the heights remaining constant vertically and the angles varying consistently. They just all don't line up. Nathan, just try showing how you derive the 60 nautical miles per degree using a flat plane and Polaris, and you'll see why Flatsoid has a headache from all that trying. He gave up and actually had both of the axes wrong. But what does work is constant distances in nautical miles for constant changes in degrees, and the height of Polaris is always the same. Angles to Polaris only work when measured on a globe from a curved surface. Even in your recent video arguing with Red's video, you pointed out why you cannot measure angles flat on a flat Earth to Polaris, and you ironically whistled right past it several times too. You even stopped to take a selfie of yourself gawking at the facts that wreck flat Earth, and you still didn't get it, or you didn't want to get it.
An altitude above, and we were able to find.
No, so what he's doing is he's taking this to, if we're going to measure a flat Earth and I can whistle past that, how do we get the height? So he's going to try and whistle past the flat Earth measurement to say that the flat Earth measurement isn't valid because of the height of Polaris.
Find that altitude or find the angle given that altitude, then by...
You'll never get the altitude of Polaris with an angle. Yeah, if you back away from Polaris, it recedes towards the horizon. When you get to the quote-unquote equator, does that mean it's smashed into the ground? Nah, it's still above its GP. It's not smashing into the ground. You can't get its height, unless you want to infer that it is literally smashing into the ground at its minimum.
By having an angle...
Oh, just so it's clear, minimum elevation angle taken from a flat Earth, because that's the only way this angle can be measured. Now, again, it hasn't been pointed out on this stream by Shane, but the only way you can get this angle is if you measure a flat Earth to get it. It's an angle. It's two straight lines. One of them's the baseline meeting the GP at 90. This is a flat Earth measurement.
So Nathan is saying it's an angle, two straight lines. One is a baseline meeting the GP at 90 degrees. This is a flat Earth measurement. By flat Earth measurements, you mean something that doesn't actually need to make sense or follow the rules of measurement or planar geometry. You can, just make it up. Gotcha, Nathan. Understand. So for the slow of understanding, what Nathan has said that wrecks himself is that flat Earth elevation angle is between the baseline and the horizontal. Is between the baseline, that is horizontal across the whole of Flatardia, and the straight line to the target, i.e. Polaris. Now Nathan backed away all the way to the equator and noted that the angle to Polaris is now 0. Now this means, as a direct consequence of measuring it flat, that Polaris is on the ground.
Nah, it's still above its GP. It's not smashing into the ground. You can't get its height unless you want to infer that it is literally smashing into the ground at its minimum.
But you just used your special pleading skills to whistle right past that little destructive fact, didn't you, Nathan? Let's assume that Nathan is actually right. Let's do a Muppet view of the flat Earth and place Polaris up here. Now let's put Dave McKeegan at 60 nautical miles times 10, which is 600 nautical miles from the GP, and so he now sees Polaris at 80 degrees elevation. You with me so far, guys? Now from Polaris, let's draw the 70 degree lines and the 60, the 50, the 40, the 30 and the 20. And 10 is way off. Now let's see if we have 600 nautical miles between each of these places on the Great Flat Earth. We can see that the distance between 30 and 40 is more like 2,000 nautical miles, not 600. Considering that a few years ago you lot were all keen to say celestial navigation only works on a flat Earth, you should know that 60 nautical miles per degree is rather critical. You cannot measure the Earth flat, not if you're dealing with reality that is. You can't measure the Earth from a single flat plane.
Oops.
It is, however, just fine to measure from local flat planes on the surface of the globe.
Okay, how do you get an elevation angle from a curved baseline, please?
So you want to see how to measure angles on a curved Earth. I guess you think that's really hard to do, nay, impossible. Actually, it's super easy, barely an inconvenience. Let me pick 3 locations on the globe and we can look up what the angle to the Sun will be at each of these 3 locations at the same time of the day. First is Farden in UK, and the second is Pretoria in South Africa, and the third point is in Malaysia. Let's just make it a nice round number to work with. The azimuth and elevation angles to the Sun all come from SunCal, which we all agree is accurately representing reality all over the Earth every time we look at it. Now here is how you place or measure these 4 angles for each location on a globe.
So first of all, let me explain what the altitude and azimuth here refers to and how I worked it out, or how I drew it in AutoCAD. So in order to determine the Sun's location from an observer, you would draw an imaginary circle around yourself, like this. You would face north, and then you would turn from north to an angle here, which is called the azimuth, and wherever the Sun was would be the azimuth angle. And similarly, the altitude angle would be the angle from the horizontal, or from the horizon, upwards to the star, or the Sun in our case, and that is the way you determine the Sun's location from a particular observer on the Earth. So to show this, I've drawn the circle from my hometown location. I've drawn a north line here, which points at the North Pole up here, and from the website, the suncalc.org website, it told me that my location is 85 degrees, or sorry, the Sun's position from my location here in the centre is 85.71 degrees. So I've gone in an eastward direction, clockwise. That gives me this line here, and then the so that's the azimuth. Then the altitude is the angle formed between this horizontal 85.71 degree line and the line of sight up towards the Sun. So just spin it around a bit so you can see it a bit better. So they're the angles we're talking about, and that's how I am determining the Sun's location on all 3 points on the Earth. Okay, let's skip to Africa. So here we are in Pretoria in South Africa, and the altitude is 22.75 degrees and the azimuth is 47.05 degrees. So let's go back to the globe, and here's South Africa, and the azimuth is 47.05 degrees and the altitude there is 22.75 degrees. So that's how I've determined South Africa. Bring it back around again. Let's look at Kuala Lumpur. So this is near to Kuala Lumpur over here. It's this North Sumatra area, just a random place that I picked. And the altitude is 60.4 and the azimuth is 315.36 degrees. So let's have a look on the globe. There it is in orange. So the azimuth is 315.24 degrees all the way around to here, and the altitude from that point is 60.34 degrees. So let's see where the lines of sight converge, or not, as the case may be, 93 million miles away. Okay, so this that you can see here is the path through the sun from the Kuala Lumpur location that we've just looked at. So if I click on that line, it tells me over here, look, it's 93 million miles. And the sun is drawn to scale as well, as was the globe, by the way. And so the sun, if I click on that, it's a sphere with a radius of 432,700 miles and a diameter of 865,400 miles. Let's turn on the other lines of sight. So we've got that one, and we've got that one. I think that's all of them. Yes. So we've got the green, which is my hometown. We've got the purple, which was South Africa, and we've got the orange here, which was Kuala Lumpur. And you can see they don't quite converge. If I take a distance from the end point of the South African line of sight and take it to the end point of the Kuala Lumpur, it is a distance of 152,000 miles apart. But it still falls within the confines of the sun, as it's so large in the globe model. So just to show what they look like all together from the globe, there are the lines of sight from all three locations.
Well, so that deserves a victory dance. Using 3 local flat tangential planes on the globe and projecting the lines of sight to the sun, they all fall within the confines of the sun 93 million miles away. How about that? Now, how about we do that on, I don't know, some sort of flat Gleason-y map looking thing, for the want of a better flat earth map which no one has managed to provide.
Anyway, let's get to the flat earth geometry. So this is the Gleason's new standard map of the world, which I've imported into AutoCAD. I've traced over the lines of latitude here with circles in AutoCAD, and because it's been scanned, the lines don't actually match the circles precisely, but they're not far off. I then offset this circle by a distance which I determined by using Google Earth and measuring distances between places and scaling this map up accordingly so that it matched, and I made sure I used places in the northern hemisphere because I know that the southern hemisphere might throw it out a little bit. So I drew the meridian on here, which is the red line again. The yellow line is the equator. These lines are all 15 degrees apart. So from the equator we've got 15 going up, and then from the equator we've got 15 going down towards the southern hemisphere. So I drew my hometown location again, west from the meridian. I drew South Africa in the southern hemisphere, counting down from these lines to whatever degree it is. I divided this distance between these lines of latitude into degrees and placed South Africa on that degree, and similarly with Sumatra or Kuala Lumpur just over here. And these angles here, you can see the orange angle here, which is the longitude angle of 97.83, and for Africa 28.24 degrees, and then for my location it's actually minus 0.84 degrees. And as you can see, they work out pretty good on the map. There would be, the red line would be going through London as the meridian. There's my location. That works out in South Africa, and that works out in Sumatra. It's pretty accurate. I then drew the line of, or the angle of azimuth. I tell you what, I'm just going to turn the map off because it slows panning down when I'm going into 3D. So here would be, this would be north, facing this way. So measuring an angle eastward from north, going around this way, this would be the azimuth angle, and then up from that angle would be the elevation or the altitude angle here, which points off up into space. I did that on all three, and as you can see, none of them converge, as is expected since I've used the SunCalc website's spherical based calculations, so I wouldn't really expect these to converge. As you can see, none of them do.
Oh dear, that didn't even get close, did it, Nathan? So measuring flat Earth from a flat plane resulted in a big old swing and a miss for Flerfs. Hey buddy, I guess Earth isn't measured flat after all.
And let's see if we can get all three lines to converge to a single point, i.e. the Sun. And if we can't, and it turns out that the values and the angles on the SunCalc website and others like it are in fact correct, then I will have to concede that the world, or the Earth, is a globe.
So who was that Flerf who really rocked the AutoCAD and slapped the dirt pizza with something shocking? Well, that was none other than Rod Durham, the golden child of the Flerf AutoCAD world. And let me just play this clip from a few years ago, just to poke Nathan and QE in their collective eyes one more time.
Would they let you play, I don't know if this has been talked about, just a short, like 1 minute clip off a video? Is that possible? Could you like send it to them? Because the 1 minute clip is the clip from Rob Durham, where he actually uses AutoCAD and puts a triangle on a sphere and then tries to get the angle between the adjacent and the hypotenuse.
Someone dig that out? I'd like to play it right now. If someone's got that video, can you stick it in Skype? Subscribe today to Rob Durham. You'll know why in a minute. Perfect. Can I show Rob Durham? Yes, I can. Okay, so this, for the audience's benefit, is Rob Durham's channel. So check it out, Be Here or Be Sphere, for Rob Durham's videos, and you can subscribe by typing in Rob Durham's name and coming to this channel. So there he is.
Okay, to briefly touch on what the guys over at Flat Earth Debate have been saying, we're going to use the exact same examples of the GP positions here. I'm going to look at it from an orthographic view. Okay, if we're standing here on the Earth, this is the angle to the celestial body. Let's take a line from our position, representing the horizon. The angle formed here is definitely not 90 degrees. And even at the position where it meets the Earth, you can't have a 90-degree angle to a curved surface. And AutoCAD will actually verify this, because if I choose the angular dimension command, and I pick this line and this line, it will give me an angle between them. If I try to pick this line and this arc, it says here, object selected is not a line. So it will just not give me an angle. And why would it? How could it? The angle will be different at every single point on that arc globe.
Thank you to Rob Durham. Subscribe today.
That's the death of the ball-tard spinning space monkey religion in a minute, under a minute.
Oh, I love how Rob finishes up there. The angle would be different at every single point on the arc. Exactly. You can get an angle. It just happens to be different at every single point. And luckily, we only want to know where the angle is at one point. Oh, did you catch what Rob did there? Here, I'll play the interesting part again.
You can't have a 90-degree angle to a curved surface. And AutoCAD will actually verify this, because if I choose the angular dimension command and I pick this line and this line, it will give me an angle between them. If I try to pick this line and this arc, it says here, object selected is not a line.
So did you see Rob's trickery that time? Well, first he measures angle A. Well, that is the angle between two parallel lines of parallel light from stars. That ain't right. Then he tries to measure angle B between the sight line and the arc. Well, that's never going to work, is it? Now, what Rob doesn't measure is angle C. He could easily do that, yet he doesn't, and we have to wonder why. But wait, it gets better. Now, once you have the angle to the tangent, the next step for celestial navigation is to find the co-angle. Minus it from 90, as 10th Man so eloquently says. And the fact that the numpties are spruiking this video by Rob shows that they actually have never even done a full site reduction or completed the celestial navigation. Okay, guess what? It gets even better. QE and Nathan both say Rob's the man. Oh, and shout out to Harry Callahan for this little gem. Now, I will steal Harry's point here. It seems that hanging around flat earthers makes one dumber. Oh, one last bit of DERP for you, Nathan. Listening to Nathan today, and he is basically just hijacking any globe earth term he can. He is now that desperate. Have a chuckle at this knucklehead's attempt to use yet another stolen concept.
For example, you can have a Cartesian plane. This would be a 2D coordinate system.
Cartesian what? Sorry, Cartesian. Stop, I didn't quite hear you. Said it too quickly. A Cartesian what?
A plane.
A plane? Okay, I think we're done. But you'll need a flat earth for that. Preferably you won't rumpus the victory dance like every other bonehead in the last 7 months. So that will need a horizontal plane of reference XY coordinates in a Cartesian coordinate system that ipso facto, because QE's here, is flat.
Actually, you will need 3 planes, not 1. And those planes are flat, but the globe, however, is not.
Yeah, we're done. You will need a flat earth to describe axial rotation.
Sorry, no. The Earth rotates around the axis which lies along the intersection of the x equals 0 plane and the y equals 0 plane. Put it another way, any xyz point that has x equal to 0 and y equal to 0 is lying on the axis of rotation.
You don't have to like it. Earth will be described as measured and with respect to this flat plane in your Cartesian plane. That's a plane. Yeah. Just so you're absolutely clear of how utterly annihilating for you that is. That's not a globe. That's a plane.
That's not a plane. It's 3 planes. Earth is not measured flat. It is measured as a sphere, and it uses 3D coordinate system to represent any point within the 3D space. So you're confused again, Nathan, and stealing a flat plane that is bisecting the globe through the equator and calling a flat Earth concept will result in you being mocked even more, and you will be dining on pot noodles henceforth. Thanks, guys.
Now chanting through me, moderators. Can you stop him from doing that, please? Yeah,
we've done.
Oh, my alarm's going off. My pot noodle needs stirring.
All right, Darl, this is what's going to happen while Nathan sorts his pot noodle out. Can you, stop going for the personal attacks and over-talking them and stuff? It would be really appreciated, man. So I'll take you off mute. You don't have to act like that, man. Be a little bit more calm, yeah.
Well, that's sweet. Oh, that thing looks awesome walking up to it over here.